Okay, you guys. So what we're going to find today is if we're talking, we're just still talking F is the function, F prime is the velocity, and F double prime would be that acceleration. And when I say F is the function, that would mean like its position or a quantity, right? Drew, how tall are you? Perfect. That's your position. That's your quantity. That's your height, right? And then F prime would be his change in height over years, right? Maybe he's increasing his height X inches per year. So that'd be his F prime. And then F double prime would be his acceleration, the rate of change of his rate of change. Annie Hoosies, let's go ahead and talk about, this is all about, we kind of work on wording today. It says people enter an amusement park at this rate given by E. So they named it E. But E is really, if it's a rate, F prime, or F double prime? It's really F prime. So I'm going to kind of write that off to my side. That's really F prime, which is really a velocity. Okay, E is people per hour that are entering this amusement park. Okay, you guys, so I'm not entering the amusement park, but other people are. At this rate, people per hours, T hours after midnight. Using your calculator, let's find E prime. E prime of 11. You guys, if here's E, how am I going to find E prime with my calc?
Math 8.
Math 8, you got it. Let's go math 8. All right, so if we got 107.958, here's what they want to know then. Using correct units, interpret the meaning of the value in this context of the problem. Here's where it gets a little annoying. Do you agree E was a rate? And we needed to find E prime, which is another rate. So we have to say the word rate twice in this answer. Oh, lame. We also need, is that rate of people increasing or decreasing? Based on this answer, what would you say? Increasing, because that's positive. Love it. And then, T hours after midnight. If we used 11 at 11 a.m., that's going to put it like real worldy. They want it real worldy. So you guys, we're going to say the rate people enter the amusement park. Using the words from the problem is a great way to kind of do less work. Is where we're going to say increasing. And then I'm going to say at a rate of, again, I had to say rate twice because we were really finding E double prime, even though they named it E prime. We're going to say 107.958. People per hour what? Nice, because E, people per hour. Whoops. E was people per hour. We found E prime. It's going to be people per hour at 11 a.m. I'm going to highlight the things necessary.
Like at 11 a.m. at the start.
Oh, totally. It does not need to be in this order. That's a good call. People per hour squared, given the unit, increasing. Yeah, and then a little context. So, yeah, you could have worded this differently. Okay, you guys. So, we're going to continue with this. So, if Q is that quantity, Q is Drew's height. Q is just a quantity. It's a how many miles it takes for us to ride our e-bikes. Where were we going to go? Rita's? Wasn't that our first destination?
That was one of the destinations.
So, that's just a distance, right? It's a number. It's not a rate. So, if they're asking about this number, this height, this length, this distance, these miles, this amount of money, and then we can describe if that number is not changing, increasing, or decreasing based on the derivative or the slope. Do you think if Drew's height is not changing, what is the rate of change of his height? It's going to be equal to 0. What if Drew's height is increasing? Then the rate of change would be greater than 0. And if his height is decreasing, he is an old man, and therefore the rate of change would be less than 0. Okay, you guys, so if they say a local bakery is opening at 7 a.m., ooh, look at this. The number of people in the bakery is B. Is that a rate? The number of people in the bakery. That's just a quantity. That's just Drew's height. This is just the number of people in the bakery is B. And then they said T is measured in hours since 7 a.m. when it opens. Is the number of people in the bakery increasing or decreasing at 1 p.m.? Yeah, I've got to find the prime because if that prime is positive or negative, the amount of people is increasing or decreasing. Okay. Do I get to use my calculator? Sure do. Can we go find B prime of what?
6.
Nice. How'd you get 6? Because I see no 6 here, but you're right.
Because 1 p.m. is 6 hours after 7.
And 7 a.m. is when the bakery opened. Good. Here we go. Let's go find B prime of 6 using our calc. Let's translate this. It says, is the number of people increasing or decreasing? The number of people, no, you're good. We're going to have to say that, Steffi, in the bakery, because I just got to get my real worldy stuff in there, is decreasing. And here we go, Steffi, at a rate of, do I say negative 28 or 28 at this point?
28.
I just say the 28.172 because I already said decreasing. The decreasing compensates for that negative. At a rate of 28.172 units.
People per hour.
Perfect. Oh my gosh, Steffi just saved it at 1 p.m. So now quantities are determined by, some quantities can be determined by 2 rates, like a rate in and a rate out. And here we're talking about penguins being born and therefore also dying. Rate in being born, it does tend to happen, but it is still sad. To find whether a quantity is increasing or decreasing, to see, we can compare the rates in versus the rate out. So penguins population, little penguins, and then it says the population is P. Is that F prime, or F double prime? Population. That's just a number, right? That's just the position of quantity. Okay, good. There are 100,000 penguins. That's a lot of penguins. That's equals 0. The birth rate for penguins is B. Is that F prime, or F double prime? Yeah, since it says a birth rate. Okay. And then it says the death rate, is D of T. F prime or F double prime? Still F prime again.
It's like, I think, gaining population still.
Is the penguin population increasing or decreasing at T equals 5 years? How could we figure out if the penguin population is increasing or decreasing if this is the rate that they're being born and this is the rate that they're dying? We could subtract them. Subtract what?
The rate at 5 years.
The rate at 5 years. Let's go find that birth rate at 5 years. Let's go find that death rate at 5 years. I wrote B of 5. Should I have written B prime of 5?
No, you're just plugging it in.
Right, I'm just plugging it in. If I just want B of 5, the birth rate at 5 years, I'm just going to plug it in, you guys. Go plug in that 5 into your equation of B. 1349.859. Good job giving 3 decimals. Death rate. So, Hytham and Lucal were like, subtract. You could subtract. Do we have to? It says, is the penguin population increasing or decreasing? You're saying increasing because
Big number, bigger than small.
the birth rate is bigger than the death rate, right? The birth rate. So, check this out. You don't have to write this down, you guys. But to your point, Lucal, if I did B of 5 minus D of 5, do you agree that that's going to be greater than 0? Could I add D of 5 to both sides to say, oh, the birth rate at 5 is greater than the death rate at 5? That could be an, what? You don't like that? No, you're exactly right. This is the exact same statement as that. Me personally, this is how my brain works. Just like, oh, the birth rate is bigger than the death rate. But if this is how your brain works, great. You don't even have to write it in either of these ways. You could say the birth rate at T equals 5 years is bigger than the death rate at T equals 5 years. That's just a lot of words. So you could say,
Would that be, would we have to write that anyway for our official reason?
I would just say B of 5 is greater than D of 5. Or Mr. Lucals, we're going to write this statement. Lucals just going to write this top line. And then I'd say, therefore, the penguin population is increasing at, actually, we don't even need it. It just says, is it increasing or decreasing? We could say yes, but at, what was my T? Yeah, at 5 years. You guys, I want to do this next one together because you can't see your graph very well, and for that I apologize. This is for Ethan Elliott. The rate that Ethan Elliott enters the museum in people per hour is M. So check this out. The rate is M that people are entering a museum. Elliott Lang going in, but M is a rate. So this is really like an F prime. T is measured in hours after the museum opens. The graph of M is below. This is M of T. This is the rate that people are entering the museum. Oh, then starting at 1 hour after it opens, right? T equals 0 to 9. People start leaving the museum, that's me, 1 hour after it opens, at a constant rate of 45 people per hour. Leaving the museum at a constant rate. That's me. Sorry. Okay, people. Find M prime of 3. All we know about M is this graph. Yeah. So if they gave me a graph of M, how am I going to find M prime? Find that slope. You guys, you can't see your graph very well, and for that I apologize. But here's when M of 3 would be there. Just so you know, these are going up by 20s over here. My bad. And down here it's going by 1s. False.
Do we have a starting number of people?
Nope. Because they aren't asking about that, right? It just says find M prime of 3.
Okay.
So they're asking for the rate of the rate, right? How am I going to find that? Say it again. 20. Up 20 over 1. Up 20 over 1. Isn't that just a slope of 20? Right? So I would just say M prime of 3 is 20. Interpret your answer in the context of this problem. M prime of 3. The rate people enter a museum in people per hour is M. So if M is a rate and we had to go find M prime, what word do I need twice? Lucal, what word do we need twice?
Rate.
Yeah. So we're going to say the rate. Elliott Lang enters the museum. People enter the museum. Is doing what? Is increasing. At a rate of 20 people per hour squared. At
3 hours?
T equals 3 hours. Yep.
Well, they haven't started leaving yet.
Well, no, they did because at T equals 1. And we're saying when T is 3. But look what they asked for. They just said find M prime of 3, Steffi. So if M is just the rate people enter, they're only asking about that rate of them entering. Part B, Steffi, says what is the rate of change of people at the museum at T equals 4? Now this is saying how many, like what is the rate of the amount of people there? So to your point, now I got to take into account my people leaving. How could I do that? What do we need to do, people?
We could use M3.
Well, we don't even need to because we need M4. Don't we need?
The same. M4 is also 20.
Whoa, wait. My bad. I feel like we're talking in circles real fast. The rate people enter is M.
Yep.
We were finding M prime here. And isn't we just want the rate of people in the museum?
Oh.
Don't we just want M
Okay.
of what? 4. We actually just want M of 4. The rate
I thought
of
it was people going into the museum. Yeah.
Yeah. Good call. What would M of 4 be? Again, sorry for the crappy graph. Do you agree that they're coming in at 80 people per hour? That was 80. Then what do you think we need to take into account? What is the rate of change of people at the museum? Well, people started leaving, didn't they? We had to take away the 45. Very good. That 45 is the rate that they were leaving, and that leaves us with 35. Let me talk about why. Anyone why didn't we do 45 3 times? Because they're just saying, what is the rate of change of people at T equals 4? 4 hours in. And it's not saying how many people were in the museum. Then we would have to take 45 away 3 times, because it started at 1. Yeah, this is just saying what's the rate of change of the people. So the rate of change is 35 people per hour. As opposed to there are 80 people per hour coming in minus 45 people per hour leaving at that one moment in time. Top one from this is from the 2021 test. The density of bacteria population in a circular petri dish at a distance r centimeters from the center of the dish. Wow. Is given by an increasing differentiable function. No cusps, no corners, no discontinuities. Okay, we got f of r is milligrams per square centimeter. Values of f of r are given. Use the data to find f prime of 2.25. F prime. They just gave us f. How could I find f prime from this table? Change in y over change in x. Where are we going to look? Yeah, between that 2 and 2.5. Let's use those 2 points. Psh, psh. Change in y over change in x. What are we going to say? 10 minus 6 over 2.5 minus 2. You guys, we would just end right there. But because it says using correct units, interpret the meaning, and this math I think is pretty good. What is 10 minus 6? 4 divided by a half is the same as 4 times 2. Final answer? 8. And I just think this is going to be easier. We could totally put this in our answer, and you guys might do that. But I'm going to do this so I don't have to write quite as much. It says using correct units. Let's first talk about what my units would be. You took this over that. How would we say that? Yeah, milligrams per square centimeter per centimeter would make that centimeters cubed. So I would say milligrams per centimeter cubed. Good. Interpret the meaning of our answer. Whoa. What do you think? We got to talk about this bacteria. The density of the bacteria. Well done. The density is increasing. Good.
At a rate of 8 milligrams per centimeter.
At T equals?
At T equals, what would it be?
2.25 what?
Centimeters.
Yes. The density of bacteria is increasing at a rate of, I'm going to say 8. Maybe you just put this pink answer right here instead of 8 because you didn't want to simplify it. You could totally put the pink answer right there. Milligrams per centimeter cubed at, instead of T, I should have said R equals, what was that, 2.25 centimeters. It should have been the rate, the density, the rate, wow.
The rate the density is increasing.
Yeah. The rate, the density of the bacteria is increasing at a rate of, you're right. I should have had a rate twice because this was a rate and girl,